All right, ladies and gentlemen, our class recording has started. So, over the past 2 days, we have been introducing the topic of stoichiometry, and we said that stoichiometry are the mass and quantity relationships between the reactants and the products in a chemical reaction. So we spent a good part of the day on Monday talking about these relationships here between between moles and the coefficients of a balanced equation, and how that how that gives us the ratio of reactants to products that we need to make the reaction happen, how we can use the molar mass to make sure that we have the right amounts, etc., etc. Then yesterday, we talked about, now I'll kind of fast forward it here, we talked about using the coefficients in the equation to figure out, if we start with one amount of something, how much of something else are we going to need or are we going to produce. And we created this, there it is. We created this conversion factor here, and we gave it a name. And what's the name of that conversion factor there?
Ratio mole.
The mole ratio, right? And the mole ratio comes from where? What'd you say? The coefficients of the balanced equation. And we said that the coefficients are like we said that the equation is like the recipe. The formulas are the ingredients, the coefficients are the amounts of those ingredients. Alright? Good there. And so here, this is the one we did right at the end of class yesterday, where we talk about starting with moles of lithium and ending up with moles of lithium oxide. And that's great, and it does give us the relationship of how much we need. But we don't measure in moles. We measure in grams. And so we have to have a way to take the way that we measure and make sure that we're maintaining these ratios that we need to maintain based on the recipe. Okay? Good there? So that's what we're going to do today. We're going to start expanding it outward. So take a look at your outline. And on the back of the outline, the problem that shows up on the very, very top of the back page says this here. Okay? So it says, grab your outline, problem up at the top, Roman numeral number 3, letter A. Okay? It says, when magnesium burns in air, a combustion reaction produces solid magnesium oxide. How many grams of magnesium oxide would be produced from 2 moles of magnesium? So, starting off, let's work the process, right? What's the first thing that we do? What are you looking for? What are you looking for, right? Ask the question. So, what is the question that this problem is asking us for?
How many
grams of
Alright, how many grams of magnesium oxide? Now, before we go any further, I will tell you this. What we're about to do, you won't have to do on the quiz or the test. Alright? So just keep that in mind, and I'll tell you when you'll have to pick it up. So, first, magnesium oxide. We need a formula for magnesium oxide, right? Look on your periodic table. Find magnesium. All right. How many valence electrons for magnesium? 2. Find oxygen. 6, right? So what's the ratio going to be of magnesium to oxygen? 1 to 1. Even though we're transferring 2 electrons, 1 to 1. So, Sartaj, 30 seconds ago, you told me, or you said, what's the formula going to be? MgO. All right. So, we've asked the question, how many grams of MgO? Now, we gather the information. One vital piece of information that we need to do stoichiometry problems is a what? Balanced chemical equation, right? So, on the quiz, you won't have to do this. I will give you the equation. You'll have to balance it, but I'll give you the equation. Here, let's just go through and as a review, make sure we understand what's going on. So, magnesium burns in air. A combustion reaction produces solid magnesium oxide. What are the reactants of this reaction going to be?
Magnesium and
Magnesium and
oxygen.
oxygen, but it's going to be O2, right? That's because it's what? A combustion. Oxygen is diatomic, but a combustion reaction requires oxygen, right? And then, what is the product of this reaction going to be? MgO, right? Solid magnesium oxide. So there's our product of this reaction. Holy cow. Okay. Roddy, go ahead. Because remember when magnesium oxide, when it forms a compound, right? 2 valence electrons for magnesium, 6 valence electrons for oxygen, trade 2, 1 magnesium, 1 oxygen, everybody's happy, 8 valence electrons, right? Now, but what we're getting at here, this is not what, Ronnie? It's an equation, but it's not balanced, right? So, we don't balance it by changing the subscripts, we balance it by doing what? Coefficients, right? So, balance that equation using coefficients. It's not real tough, especially seeing as how you did this in lab last week. It looks like this. Yeah? All right, good so far. Good? Yes, Matt.
Can you? Oh no, never mind. Okay, never mind. Because that's 2 moles.
Yeah.
I was gonna say, like, can you just put the subscript 2 next to the oxygen, but
Can't do that.
That'd be 2 magnesium.
Because magnesium and oxygen, when they form a compound, it's not 2 oxygens to 1 magnesium. It's 1 to 1, right?
Yeah.
All right. Now, stoichiometry problems are conversion problems. Conversion problems get rid of bad units and give us units that we want, right? What's the bad unit that we're trying to get rid of in this problem? Not just magnesium. Moles of magnesium, right? We're starting with this. But do we want moles of magnesium? No, we ultimately want what? Grams of magnesium oxide, right? So, we start off 2.00 moles of magnesium, right? That's what we're trying to get rid of. Time sign, fraction bar. What unit has to go on the bottom of that conversion factor? Moles of magnesium have to go on the bottom of that conversion factor. Okay? Now, this is where this problem gets a little different. Conversion factors get rid of units that we want, get rid of units that we don't want and end up with units that we do want. Ultimately, what unit do we want our final answer to be? Grams of what? So, conversion factor wise, right, that's what we would do. Right? But that's a problem. Okay? We've converted from moles to grams before. What do we use to convert from moles to grams? Not the atomic mass, the molar mass, right? They're a little different, but numerically they're the same thing, right? But the molar mass relates from converting 1 mole of something to grams of that same substance. Can we go from moles of one thing to grams of something else? That's not a valid conversion factor, right? So, we can't build this conversion factor. We can't have moles of one thing on one part of the conversion factor and grams of something else. But we did learn yesterday that we can convert between different parts of an equation using the mole ratio. So we can put moles of magnesium here, and then we can put moles of magnesium oxide on the top. That's a mole ratio. It gives us the relative amounts, the ratio of ingredients in this recipe. And when we're building a mole ratio, where do the numbers come from? Nope. Mole ratio. Moles of one thing to moles of something else. Where do we get the numbers from? The coefficients. So what number is going to go on the bottom of this conversion factor? 2. And then what number is going to go on the top of that conversion factor? 2. And then when we do math, these will cancel, and we'll be left with moles of magnesium oxide. But is that what we want? No. We want what? Grams of magnesium oxide. So what do we do, Sartaj?
You simplify it.
Nope, not yet. Heard it.
Yeah.
Another conversion factor, right? If we don't have the units that we want, we put another conversion factor.
So on the bottom it's got to be moles.
So on the bottom of this conversion factor, it has to be moles of magnesium oxide. Because we're trying to get rid of that unit. And then what's going to be on the top? Grams of magnesium oxide.
Yeah.
We can do that, right? We can convert between moles of one thing and grams of something else. Now, here's an important thing to remember. And I will tell you, in the past, students mess this up frequently. So I'm going to try and point it out to you so you don't mess it up as well. Okay? Converting between moles and grams of a substance, we use the what? Nope. The molar mass, right? And Kat, we get the molar mass from the what? Periodic table. Okay? Now, in this case, first, to find the molar mass of this compound, what are we going to have to do? What's in this compound? Magnesium and oxygen. How many of each? One of each, right? So to find the molar mass of a compound, you have to go to the periodic table and add up the molar masses of all the atoms in that compound. Okay? So, go to the periodic table, find magnesium, find oxygen, what is it? 40.31. Okay? And that goes in for grams. Now, does that make sense where we got that number from? Okay. Now here's the part that people mess up. That people have messed up in the past. Not saying you guys are going to do it, but it happens in the past. So, that number is the molar mass. It is the mass of how many moles? 1. Okay? The molar mass corresponds with 1 mole. So when we are converting from moles to grams, or vice versa, that's going to be a 1. Even though in the previous conversion factor, we had moles of magnesium oxide and we put a 2 in front of it. We did that because we were converting moles to moles. This is the mole ratio. The number in the mole ratio comes from the coefficient. This is not the mole ratio. This is the molar mass. And the molar mass is always based on 1 mole. So even if you have a substance in your equation that has a coefficient, when you are using the molar mass, it's always 1 mole's worth of stuff. Okay? Pat, go ahead. Okay. So now, right, when we go and do our math, right, Stephen, you told us that in our, well, one more thing, right? Then this will cancel and this will cancel, and the only unit that's left now is what? Grams of magnesium oxide, and that's what we want. Stephen, what happens in our mole ratio here? 2 over 2 is just 1, so when we do our math, 2 times 40.31 will give us 80.62. But how many significant digits does our answer need to have?
Three.
Remember that our significant digits are always based on the number that we started with, and there are only 3 significant digits in that number because both of those zeros are significant because they're after the decimal. So your answer here should be 80.6 grams of magnesium oxide. All right, does that make sense? Yep. The sheet that I gave you today, mass mole relationships. Mass mole relationships. Okay. Looks like this. Let's take a look at number 5 down at the bottom. Number 5 at the bottom of mass mole relationships says chlorine gas. Chlorine gas can be produced by passing electricity through a solution of sodium chloride as shown by the equation. There it is. It says if the solution contains 250 grams of sodium chloride, how many moles of chlorine gas are produced? So, let's go with the process, right? What's the first thing we do? Ask the question, right? What's the question here? How many moles of chlorine gas, right? So, and as you can see here from this equation, chlorine is one of our diatomics, so chlorine gas is Cl2. Okay? All right, now that we've asked the question, what do? Balance, right? There's the equation. Balance it. This is what I would have you do on the test. I'll give you the equation, and then you'll have to balance it, right? So I won't make you figure out the equation, but you will have to balance it. Don't start with oxygen. Actually, you can start with oxygen in this one. But all right. Good there? All right. So now, conversion factors, stoichiometry problems are getting rid of bad units and giving us units that we want. All right, so we start off. What are we trying to get rid of in this problem? What did they give us to work with at the beginning? Grams. Grams of what? Okay. So we know that we have 250 grams of NaCl. Okay? That's what they gave us to work with. But we want to turn that 250 grams of NaCl into moles of chlorine gas. Right? That's what it's asking us for. So, time sign fraction bar. What unit has to go on the bottom of our first conversion factor? Grams of NaCl. So you got to get rid of that. Ultimately, we want to end up with what? Moles of
chlorine gas.
more moles of Cl2. Can we put moles of Cl2 on the top of that conversion factor? We can't go from grams of one thing to moles of something else. But we can go from grams of NaCl to moles of NaCl. Right? In the previous problem that we did, we used the molar mass second. Here, we have to use the molar mass first to get a number in moles, right? But do we want to end up with moles of NaCl? No, right? So we're going to need another conversion factor. What unit has to go on the bottom of our second conversion factor? Moles of NaCl. But then, what can we put on the top of that conversion factor?
Chlorine gas.
Moles of Cl2. That's okay. That's our mole ratio. Alright? Now, let's start putting numbers in. Let's do the mole ratio first. Right? The mole ratio is the conversion factor that has moles of one thing to moles of something else. This one right here. Where do we get the numbers for our mole ratio? The coefficients. So what number is going to go on the top of this mole ratio? What number is going to go on the top of this mole ratio?
I don't get how you do that. I don't get how you do that. Yeah, because there's only one CO2.
Oh, 1 mole.
And then what number is going to go on the bottom of this conversion factor? All right, good there. Now, let's do the first conversion factor, right? When we have a grams number, that's our molar mass. Where do we get our molar mass from? Periodic table. In order to find our molar mass for this compound, what are you going to have to do?
Add them up.
Add together
Chlorine and
sodium, right? 1 chlorine, 1 sodium. Okay.
Cancel it.
But, like we just talked about, the molar mass is the mass of how many moles? 1 mole. Even though in our equation we have a coefficient of 2 in front of NaCl, that doesn't matter when we're using the molar mass. That always goes 1. That shows up in our mole ratio, not when we're converting. Okay? Now it's some math. Go. Yeah. How do we find the molar mass of a compound? How many atoms are in this compound? Do you really get it, or are you just saying that because you want me to stop asking you questions? Yes, Rachel.
Writing the mole ratio, how do you know which number goes on top?
Well, we set up the units first, right? So we know that here, so we knew grams of NaCl is going to cancel here, right? And we turned our grams of NaCl into moles of NaCl. And that means moles of NaCl has to be on the bottom here, right? So that this can cancel with this. Does that make sense? Units always come first. The units dictate how we set up the conversion factor. So we got to cancel units we want to get rid of and leave us with units that we want. Yes, Ronnie?
Is 2.18 or 1/4?
What is it?
Well, it's like 2.13894592.
Okay. So, how many significant digits in this number? 2. So what should our final answer be? 2.1.
Would it really be? Really?
Yes.
I know.
All right. How's that? Good so far?
Yeah.
Okay. So let's, I think it might be beneficial for us to do one more example like this.
Yeah.
Okay. So why don't we do number 2 on this page? Number 2 on this page. Go ahead and work on it with the person next to you. I'll start working the problem up on the board. All right. So number 2 from the mass mole relationships.
Okay, let's go. Show me your card. What are we looking for? 30 grams is 8. Grams? grams of zinc oxide?
Yeah, it is.
So the question is how many
Where's my pen?
grams of zinc oxide?
ZNO.
Where's my pen?
There we go. Balance.
How many grams of Z? Okay, we gotta balance now, guys. So plus C.
That's easy. The balance chemical equation is 2
Shut up. No, it's 2. No, it's 2 zero.
It's 2.
So am I. Look, there's 2 zincs now in each, 2 oxygen,
Okay, guys, now what? Now
and
we're
1
working fast.
carbon.
Come on, man, slow.
2. Look at the board.
I already done it, bro. I already balanced. Now we gotta the conversion phase.
2 ZNO plus 2 ZNO plus C.
Okay,
Yeah,
5
2
moles.
ZN.
5 moles of carbon. And then you times this.
Okay, now we need to use
I'm already doing it. 5 moles.
carbon. Got it.
Okay.
Okay.
And then we gotta use,
Now we use the mole.
we have to find how many grams is 1 mole.
Yeah, but you can't do a conversion factor. Yeah.
Yeah, you can.
No, you have to do another app.
I know. Yeah, but we gotta go one at a time. That's what I'm saying. Okay, so carbon. Where's carbon? Carbon. 12.0.
How do you do this equation down to 12?
I don't know what that is. It's what we're trying to get, so we have to get more we need to get
No, I got it. Look at this. Look at this right here.
more, yeah, well, you're right.
1 mole of carbon. 1 mole of carbon on the bottom, and then 12.01 grams of carbon on top.
Yeah.
Bart, you're gonna find that in all these stoichiometry problems, I'm gonna give you one number to work with.
Okay, and then you go.
Start with that
Then we're
number,
gonna get rid
and then
of
start getting rid of it, right? So if this is moles of carbon, my first conversion factor has to have moles of carbon on the bottom, right? I can go from moles to moles of the same, moles of one thing to moles of something else in the same equation, right?
I was doing ZN. I was doing ZN. I knew. Yeah, but I don't know how you do the ratio. It says the mole to mole and then grams to mole.
How do you get those ratios? Where do those ratios come from, Jafar? What do we,
Okay.
what do we call that? What do we call that conversion factor? That's our what?
Okay, and then we gotta change
You get it from the, what do we call the conversion factor that has moles and moles in it?
Mole to mole mass.
mole
Mole to mole.
The mole ratio, Jafar.
I got it.
I got it right. See?
And the mole ratio comes from here.
Remember,
Remember, the equation is the recipe, right? It gives us how much of this to how much of this.
the moles of zinc. Moles. I mean grams at the bottom.
No, you have to find how many grams.
The conversion factors aren't measurements, they're like known values. Significant digits are based on measurements, always from the very, very beginning.
Wait, 1 mole.
We gram of what? Zinc, yeah.
And then equals, let's see, zinc. It's 65.41. 65.41. Heavy. It's 81.41.
Grams of what?
Oh my, wait, what is it?
What's the mole? Type these up.
What's the time?
Remember, Jules, if you want, think of that as being, think of the original number being 1. If you want to.
81.41.
And then you gotta multiply across.
This would be what?
814.
Got that.
Seriously? Oh my god.
Mole of
No, but it's not right. You're
Yo, we got it. Point. Wait.
No, you're right.
Only 814.
grams of ZNO. gotta finish before Mr. Punch.
2 to 1 with
Come on, you guys.
Come on, guys.
You guys, you gotta do this. Now,
Yeah, you're right, Pat.
the whole page now. Let's do it.
He's not doing the whole page. No, we're done. I gotta.
I think
Let's go.
No,
Yeah, I know. I did that too.
I always memorized my thing.
Did I do it?
Good job, boys.
Too far. Dang it. I see like I'm so close. I got it right now. Go here, Fox. Juliana, get it?
Alright, so to wrap this up, okay, first, we did the mole ratio because we got to get rid of moles of carbon and we went to moles of zinc oxide. Keep in mind in this last conversion factor, even though there is a 2 coefficient in front of the zinc oxide in the equation, that doesn't show up when we're using the molar mass. The molar mass is based on 1 mole of something. Yes, Ronnie? Whenever we have a conversion factor that has moles to grams, moles is always 1, grams is always from the periodic table. Whenever we have moles to moles, that's when we use the coefficients. Okay? Good there? So, for homework tonight, the rest of that sheet, answers are posted online. Okay? Tomorrow, we will add the last step. If you get this, the next step is pretty easy. So you'll have a good amount of time tomorrow in class to work on example problems. If you want, we have about 6 minutes left. If you want to talk to me about course recommendation stuff, we can do that. All right?
Wait, Mr. Spicer, did you recommend